Okay, part 3, line of regression. So let me quickly remember or try to remind you what happened in 6.2. I drew a line, but the line wasn't perfect. Like the points weren't exactly the same points the equation was giving me that was on the table. So when you're doing the line of best fit, you're going to find errors. Now, the line of regression is supposed to be the line of best fit with the least amount of errors. It's the line that's going to be the closest to representing the data. Okay, now, if you see this table, normally you would graph it, draw the line, and pick 2 points to draw your line of best fit. Now, here's the thing. If you drew it, it would look like this, and there's no points, right? So you would have to try to figure out, okay, what 2 points can I use? So you would have to randomly pick 2 points on the line to use because none of the points are actually on the line. But here's something you can do for the line of regression. To find the line of regression, you're going to use a calculator. It's the best way to do these problems. So what I'm going to show you for a good amount of this time is how to use a graphing calculator online for this, okay? So we're going to take these points and we're going to put them in a graphing calculator. Now, on your homework, I put a link to this page, okay? So please click on that link when you're doing these homework problems and even when you're doing the quiz. But these numbers are not the same numbers, okay? So you have to change the table. So the good news is you can edit this page. It doesn't stay the same. So I can just delete all the numbers on here. Now, for my table, a lot of the numbers are the same. I just need to add a couple more. So actually I don't need this many down here. So I can just hit delete and they go away. All right, so those are my x values, and right here I'll put my y values. 1, 3, 2, 6, 7.23, 7, 8.9, 11.5. And there you go. This is the graph that was on my paper. Now, again, I can't use those points, but here's the great thing about our graphing calculator. There's a command to find the line of regression. Guys, this is the line of regression right here. And it will automatically give you what is the best line of fit, or the line of best fit with the least amount of errors. So it's the line that's almost perfectly in the middle of the points. And that's kind of what you're looking for the line of regression, okay? So if you notice these numbers, I'm going to highlight these numbers. I'm going to write them down on my paper really quickly. And actually I'm going to round to the 100th. Yeah, I'm going to round to the 100th. I'm not going to use all of these numbers, and neither do you. You really don't. Okay, so now let me go back to my screen. All right, so I entered that. I have that graph. Now these are the numbers that it gave me, okay? And I guess I didn't have enough room for B. But here's the great thing. If they want the line of regression, guys, you're using mx plus b. So it gives you those numbers here. Now, depending on your calculator, it might say A and B, but it's the same thing. The first one goes first. This is going to be 1.42x minus 0.59. And guys, this is my line of regression. This is the answer. And my calculator did most of that work. The only thing is just make sure you're organized, you enter it correctly, and it should look identical to whatever you would make. Okay, and this is actually the best way to do these problems, using the line of regression. Now there is one more thing I want to highlight. This. Guys, this is called the correlation coefficient. And it basically talks about how good this line is. Like, not just the positive association, not negative association, but how close it is to the data. Because in the past, when I made you give me the association, you guys could tell me, okay, this line is going up, that's positive association, that line's going down, that's negative association. But now, if you look at this one is also negative association. But would they be considered the same kind? And the answer is no. You can actually give it a number. There's a number to talk about how close that line is interpreting the data. And that's what the correlation coefficient does. So we have to talk about this. Usually in the calculator, it's labeled as R. Okay, so whenever you see R, we're talking about the correlation coefficient. Okay, now it's within a range. It's between -1 and +1. And of course, in between them is 0. So your numbers for this are going to be in between this. So what's the point of this? Well, if you notice, half of it is positive, the other half is negative. So if you're positive, if you have a positive correlation coefficient and you're on this side, you have a positive trend, you have a positive correlation. If it's on this side, you have a negative correlation, okay? Now, if you look at the line that we drew for this problem, what does that look like? Positive or negative? That's going up. It's a positive correlation. So it's on this side. The number's going to be on this side. Now here's the number that it gave us, 0.96. When your number is close to 1, it has a very positive and strong correlation. So this line has a strong positive correlation. Now, if instead of 0.9, let's say it was 0.1, the closer it is to 0, and even on this side, if your numbers are close to 0, then it's a weak correlation. It's weak. Now it could be positive weak and it could be negative weak. It just depends on which side of 0 it is. Now just imagine if this was over here. What if it was a negative 0.96? Well, that's also strong correlation, but instead of being strong positive, that's strong negative correlation. So when you're interpreting correlation, you're not just saying which direction it's going, there's an actual number that gives you the strength of the correlation. So you can have strong correlation, you can have weak correlation, and if you're in the middle, like 0.5 or negative 0.5, then that's like moderate correlation, okay? But basically all we're saying is, how close is this line to the data? If it's really close to it, then it's strong. If the points were really far away, you would get weak correlation. And that's correlation coefficient.